This video will cover question 51 of the Specimen Section 1 PBSAA paper. Please note that our solution will be the same as the equivalent ENSA Specimen Section 1, question 68. In question 68 we're given the following graph and we're told that it represents a student carrying out an experiment on an enzyme-catalyzed reaction using amylase. The amylase was added to the substrate and then left to react, and this graph shows the results of that experiment with time on the x-axis. We're then asked what the label could be on the y-axis out of 5 possible options. Okay, so in all of these we have to bear in mind that we have a rise and a fall with respect to time. Okay, so could it be enzyme concentration? Well, we know that can't be the case because we're already told that amylase was then added and left. During the process of enzymatic reactions, enzymes aren't broken down or used up, and they certainly don't increase then fall in concentration over the course of a reaction. If, for instance, this were talking about free enzyme active sites, then perhaps this would be different. But this is talking about raw enzyme concentration, which doesn't vary with time. Moving on to B, enzyme substrate complex formation. Now this is something to consider. We should remember what the equation is for enzymatic reactions. We have enzyme plus substrate forming enzyme substrate complexes, which then forms enzymes and products. So this is a process that happens with respect to time, and we can break down our graph and see that the highest level of our y value corresponds to the point where we would have maximal enzyme substrate complex formation. So during the middle of our reaction we have maximal enzyme substrate complex formation, at which point the concentration of substrates starts to fall, becomes the limiting factor, and therefore we would have reduced numbers of enzyme substrate complex formation, as we would already move to the phase where we have more products than we have substrates. Moving on to C, could it possibly be pH? Well, although the pH curve does follow this shape, on the x-axis we have pH under normal circumstances, and on the y-axis we have enzyme activity. So this is a misleading red herring, and the same can be said for its substrate concentration. Substrate concentration does fall, but it never rises to a peak and then falls, it just falls as the experiment proceeds. And the same can be said for the product concentration. We would expect that to slowly rise as the experiment goes on, not rise then fall. So we can say our answer is B.